This video provides a summary of solving inequalities. We're going to look at linear inequalities first. Basically, to solve linear inequalities, you solve them just like the related equation. Our first linear inequality here is 5 minus 3x less than 8. We would solve that just as if it were 5 minus 3x equals 8. We could subtract 5 from both sides, and that would give us negative 3x less than 3. Then we divide both sides by negative 3. Now, when we multiply or divide both sides by a negative, we have to switch the inequality sign. So the less than is switched to greater than. So the answer is x greater than negative 1. So in summary, to solve linear inequalities, you solve them just like an equation. You add or subtract from both sides, and you multiply and divide both sides by the same quantity. But if you divide both sides by a negative, or you multiply both sides by a negative, you switch the inequality sign. Otherwise, you don't switch the inequality. The other type of inequality we looked at was absolute value inequalities. There's two types of these. We have the less than absolute value inequalities, and an example here would be absolute value 2x minus 1 less than or equal to 4, and then we also have the greater than absolute value inequalities. An example here is absolute value of 2x plus 2 greater than 6. The less than absolute value inequality is solved by rewriting as a double inequality. Absolute value of 2x minus 1 less than or equal to 4 is rewritten as negative 4 less than or equal to 2x minus 1 less than or equal to 4. We solve this by adding 1 to all three parts, and then we divide all three parts by 2. And the answer we end up getting is negative 3 halves less than or equal to x less than or equal to 5 halves. You'll notice that with less than absolute value inequalities, our solution interval is always trapped in between two values on the number line. So it's always going to be some middle region. Now let's look at greater than absolute value inequalities. The example being absolute value of 2x plus 2 greater than 6. For greater than absolute value inequalities, we rewrite as two separate inequalities. We rewrite as 2x plus 2 greater than 6, and also 2x plus 2 less than negative 6. We solve both of these, and we get solutions x greater than 2 and also x less than negative 4. This gives us two solutions on the number line that point outward. One solution points to the right, it's x greater than 2. The other solution points to the left, it's x less than or negative 4. So greater than absolute value inequalities always have solutions that point outward. The less than absolute value inequalities always have a solution that is trapped between two values. Now I'm going to give an overview or a summary of solving polynomial and rational inequalities. Let's look at polynomial inequalities first. We're going to look at the polynomial inequality x cubed minus 4x less than or equal to 0. The way you solve this is to find the critical values. You have to solve the related equation x cubed minus 4x equals 0. That factors out as x times x squared minus 4, and if you solve that factored equation, you get three solutions: 0, x equal 2, and x equal negative 2. These are the critical values. These are the values you plot on the number line, and that breaks the number line into 4 separate regions. Now we have to test each region. We test to the left of negative 2. If we plug in negative 3 into our original inequality, we get a true statement. Because negative 3 cubed is negative 27 minus 4 times negative 3, that's negative 27 plus 12 is negative 15. That's less than or equal to 0. It's true. Then we check the region or the interval between negative 2 and 0. If we plug in negative 1, we get negative 1 cubed is negative 1 minus 4 times negative 1 becomes negative 1 plus 4, or 3. 3 is not less than or equal to 0, so that means this interval from -2 to 0 is not part of the solution. Then we check the interval from 0 to 2. X equal 1 is a good test value. We plug it into the original inequality. We get 1 cubed minus 4 times 1. That makes -3. That is less than or equal to 0. So the interval from 0 to 2 is part of the solution. And then lastly, we check x equals 3, which is in the interval to the right of 2. If we plug 3 in, we get 27 minus 12, which is 15, and that's not less than or equal to 0. So the intervals that work are the first interval to the left of -2, including -2. So x less than or equal to -2. And the other interval that works is from 0 to 2, including 0 and 2. So we have 0 less than or equal to x less than or equal to 2, and that's our solution. Now let's look at rational inequalities. We're going to look at the rational inequality x minus 1 over x minus 4 greater than or equal to 0. This one's already in the form we can work with. It's all combined into one fraction on one side and 0 on the other. So we have to find the critical values. We find the critical values by letting the numerator x minus 1 equal 0. That gives us the critical value 1. We also let the denominator x minus 4 equal 0, and we get the critical value x equal 4. We plot these on the number line. Now it's greater than or equal to, so we'd use closed circles, except x equal 4 would give us division by 0, so we leave that circle open. Now this divides the number line into 3 possible intervals. To the left of 1, between 1 and 4, and to the right of 4. So let's check to the left of 1 first. If we pick x equals 0 and plug it into our inequality, we get 0 minus 1 over 0 minus 4. That makes a negative over a negative, or positive, and that is greater than or equal to 0. So the interval from to the left of 1 works, so we shade everything to the left of 1, and we also include 1 as well. Then we check any test value from 1 to 4. 2 is a good value to plug in. We plug 2 into the inequality. We get 2 minus 1 over 2 minus 4. That makes a positive over a negative, and that's negative, so it's not greater than or equal to 0, so the interval containing 2 is not part of the solution. Lastly, we check the interval greater than 4, and we probably would want to pick x equal 5. If we plug 5 into the inequality, we get 5 minus 1 over 5 minus 4. That gives us 4 over 1, which is positive 4, and that is greater than 0. So the interval to the right of 4 works. We don't include 4 because that would give us division by 0, but everything to the right of 4 is part of our solution. So our solution becomes x less than or equal to 1 or x greater than 4. If you want more detailed examples of polynomial and rational inequalities, see the separate videos titled Polynomial Inequalities and Rational Inequalities, and there I go through several problems step by step.